I think you did the. Have you got any number there which is disturbing?
No, teacher.
On a set.
Teacher, no.
Because now we want to leave that and we come to we got something else so that we can move ahead. At least we have done many topics. To people who have been not studying, they are really behind. So at least you people who have attended, at least you have done something very great as we prepare to go for Christmas. So I think the questions about sets we finished, unless or otherwise. In questions of straight lines, we looked at them. Gradient, we looked at them. Okay. Let me see which topic we can go through. Maybe quadratic equations, we looked at them. Quadratics. I think now what I can take you to is let me take you to what we call inequalities. Yeah, let me take you to inequalities, so that this topic is also done. Let me take you to inequalities. Inequalities. So let us write the new topic, inequalities. Inequalities. Good enough. Not something new. You have always looked at this inequalities. Okay. So this is the new chapter. So at least online we have looked at many things. We started with logarithms, indices. Logarithms, indices, we had looked at them earlier on. Simultaneous equations like that. Now at this moment, let's go to inequalities, and here we begin by saying an inequality is an expression that contains the following variables. Okay, I mean the following symbols. Let us not say variables. The following symbols. Okay. So the symbols which we are going to list them, which are found in inequalities. So the first symbol which is found in inequalities, it looks like this. This is one of the symbols. Okay. So this symbol here, so this symbol we can say which stands for greater than. This is less than, not greater than. So this one here, less than. Okay. Yeah, less than. That's the meaning of this symbol. In B, we can have another symbol in inequalities. This one here like that. So this symbol, which stands for greater than, or if we don't say greater than, we can say more than. That is the second symbol there, which we can find in inequalities. The third symbol, which we can find here, is this. This one here. Okay? These symbols we have looked at them. It's not new. They are not new. So this one here, which stands for less than, less than or equal to. That's the meaning of this symbol. Less than or equal to. Then we have also this one. This one here stands for this one stands for greater than or equal to, like that. Greater than or equal to. So these are the four symbols which are found in what? In inequalities. So when you are looking at inequalities, these are the symbols which we have to find there. Okay? So we can say again on a paragraph. On a paragraph, we can have that the following are some of the examples of inequalities. Okay, so the first example, we can have an inequality like this. That is 2x minus 3 less than or equal to 10. This is an example of an expression which is an inequality. Okay? Another one we can have like this. Another example, we can have 2x minus 2. This is less than 4x. That's plus what? 6. This is another example of an inequality expression. We can have another one. We're just trying to write down some examples. Another one we can have like y squared plus 2y plus 1, that's being greater than 0. This is another example of an inequality. Okay, like that. Then we can have another the fourth one. The fourth example of an inequality, we can have like 3, that is over 8, that is n plus 1, that's being greater than or equal to what? N. Yeah. So these are some of the examples of inequalities, like that. Okay, so we have to take note of them, like that, when we come to inequalities. So after that, we are going to come here and we see how to solving inequalities. That's the major thing which we have to look at here. Solving inequalities. Solving inequalities. Solving inequalities, we need to know how to solve them. Okay? So solving inequalities, we are going to see the methods which we use or which we follow if we are to solve them, those inequalities. So I think here we are going to say like this, that when solving inequalities, comma, the following. When solving inequalities, comma, the following rules may be put into consideration. So here, when we are solving inequalities, there are some rules which we follow. Okay? And those rules, they may not apply to those other expressions, but here they apply because these are inequalities. Okay? So what are those rules? The first rule which we have to know is this, that multiplication on both sides of the inequality, okay, symbol of the inequality symbol by a positive number, okay, does not change the order, of the inequality. Okay? Does not change the order of the inequality. For example, we are going to see here, okay, that multiplication on both sides of the inequality symbol, here there's M, here, inequality symbol. Yeah, multiplication on both sides of the inequality symbol by a positive number does not change the order. Okay? Does not change the order of the inequality. Okay? So an example which we are going to take note here, like we can say, for example, e.g., we may have an inequality equation like this. Here I have here 2x minus 3, that's less than what? 4x and then plus what? 6. Now when you look at this, and then we say there's a step, we introduce a step here. We say, let's multiply on both sides by 2. Okay? Multiplying that's both sides by what? By 2. Let us see what we obtain. When we multiply both sides by 2, it means that here we are going to multiply 2 this side, 2 into brackets. That's 2x minus what? Minus 3. Then we do the same on the other side. We are multiplying both sides by what? By 2. So here we have said that when you are multiplying both sides by a positive number, or when you multiply both sides by a positive number, the order of the inequality symbol doesn't change, it remains. So if the inequality symbol was less than, automatically it will still remain less than, okay? So here we get 4, that is x. 2 times 2x, we get 4x. 2 times 3, we get negative, that is 6. And this will be less than. 2 times 4x, we get 8x. And then 2 times positive 6, we get 12. So this one here, during multiplication by a positive number on both sides, it doesn't change the order of the inequality. Okay? So I think that is well noted. So we have to take note of that. That is what? A. Okay? Then after that, we need to look at the second one. The second case. Okay? That is the adding a constant on both sides of the inequality. Leaves the order of the inequality unchanged. Yes, unchanged. Okay. For example, okay. So now here we are going to see these things which we do. Adding both sides, let's add both sides by this. Let's subtract both sides by this. Okay? So these are the things which we are trying to look at. So now let us see. We had our example there. That is 2x. That's 2x minus 3 less than 4 what? 4x. And this is plus what? 6. So we are saying when we add both sides by a constant, adding, it doesn't change anything. Okay? Like let us see. Let's try to say we are adding. Okay? We say we are adding both sides by 5. So 2x minus 3, and then we add 5 plus 5. Then also we do the same on the other side. 4x, that is plus what? Plus 6, and then plus what? 5. Okay? So here what are we doing? We are adding 5 on both what? Both sides. We are trying to add 5 on both sides. Okay? So when you add 5 on both sides, nothing changes. The sign doesn't change. So this side you will get 2x. It will be 2x plus what? A negative 3 plus 5, we get positive 2. And then the other side, it will be 4 what? 4x. 6 plus 5, we get what? 11. So the sign doesn't change. You can see the sign, the order. The order of the inequality doesn't what? Change when you add a constant on both the sides. Okay? So we are going slow but sure so that you know how to do all this work. Okay? So that is B. Now C, let us see during subtraction. Subtraction. Because you may find during subtraction something must happen. Okay? So let us see during subtraction. Now here they are saying that subtraction of a constant. Subtraction of a constant from both sides. From both sides of the inequality symbol. Of the inequality symbol, okay, leaves the order of the inequality. Leaves the order of the inequality unchanged. Okay. Still take an example. Still that very number up there. We are still going to use that one there. Okay. So let us see. There we had used our number is z, or our equation is 2x minus 3 less than what? 4x, which is plus what? Plus 6. Now in this case, let us say we subtract. Let us subtract 4 on both sides. So when you subtract 4 on both sides, this side you are going to have 2x minus 3. So we are subtracting 4. So minus 4. The inequality symbol has to remain the same. The order has to remain. So the other side we have 4x plus 6, also minus what? 4. So I've subtracted 4 on both sides. So this side I'll have 2x and then minus what? Negative 3 minus 4 we get negative 7. Then the opposite side 4x, it will be plus what? 2. Plus 2. So you can see there is nothing. The symbol has to remain, even though we subtracted 4 on both what? Side. The order of the inequality symbol has to remain unchanged. Okay? After that, we go to D. We go to D. D we are having D. Now D we are going to talk about multiplication. Multiplication. Okay, we can say multiplying or dividing. Okay, both sides of the inequality symbol. Okay, by a negative number, comma, by a negative number, comma. Okay, by a negative number we can say reverses the order of the inequality. The order of the inequality. Yes, that's the only situation which reverses the order. Okay, that is when the moment you multiply or you divide both sides of the equation by a negative number, the order of the inequality is reversed. Okay? So let us see. When you take an example, like when you take an example, let us say we are having 3x plus 1 greater than or equal to 4x, that is minus what? Minus 5. Okay? Now, the moment you say, let us multiplying both sides by -2. Now, the moment you say you are now multiplying by this -2 on both sides, that is -2 into brackets 3x plus what? Plus 1. Okay? The moment you do this by multiplying both sides by that negative digit, this sign immediately, don't even wait, reverse it. If it is greater than or equal to, like in this case, reverse it so that it looks like this, less than or equal to. Okay? Because you are multiplying both sides by negative what? By a negative digit. Okay? Like that. Okay? So this is what happens when you multiply both sides by a negative what? Digit. The negative reverses the inequality symbol. The inequality symbol was greater than, but after multiplying, it becomes less than or equal to, like the way you see in this what? In this number, like that. Okay? So you have to know that very, very carefully when you are working out inequalities. Okay? So then here we can say similarly. So similarly, that is like now, if you say you are performing a division, okay? Similarly, you may be having something like this. Still, we are having the same equation. Let us say still the same equation is 3 what? That is 3x plus 1. It was greater than what? Or equal to 4 what? X, and then minus what? Minus 5. So now in this case you say, let me try to do what? Let me divide. Okay? Divide. Okay, can say dividing throughout. Dividing, let us say both sides. Dividing both sides by, let us say negative what? -2. Okay? Let us say -4. Because we have already raised the -2 up. So let us say dividing both sides by -4. So let us see what we get when we divide both sides by -4. We are going to get this 3x. We divide it by -4. Okay? We get the other positive 1, also divide by -4. Now, because we are dividing throughout by negative number, this inequality symbol reverses. It was greater than or equal to, now it will become less than or equal to. Okay? And then here it will be 4x. And then also we divide it by negative 4. And then minus 5 divided by negative what? 4. So whenever you divide by negative value, please don't forget that, because that is very, very common in the numbers when they tell you to simplify or to solve those inequalities. Okay? You have to always know that the negative reverses. Well, so long as it is in when you are dividing and multiplying. But when you are adding or subtracting, they don't reverse anything there. So this is what happens in that case. Okay, so I've shown you everything which you're supposed to know, so that we can now be able to head. We go to numbers and we solve them. Solving what? Inequalities. Clear? Or there's a question? Okay? So there's no any question, eh? Okay. So let me take you to the examples. Yeah, I can take you to the examples of solving linear equations. So remember, we have linear equations, we have quadratic. Let us begin with linear inequalities. Linear inequalities in one unknown. In one unknown. So let us see solving this linear equations in one unknown. Okay. So on a paragraph, we can first say like this, that a linear equation, okay, a linear inequality. Linear inequality is an inequality for which the highest power of the variable is 1. The highest power of the variable is 1. Yeah, so the examples, when you come to the examples here, of course, okay, so the examples here which we can say find, that's saying find the value of x. The value of x for which so we have here the examples for which part A we have x minus 1 less than or equal to 5. This is A. B, x plus 2 greater than what? Greater than 6. C, we have 2x. So this one they want us to solve them. Here we have 2x minus 3 less than or equal to 13 less than or equal to 13 minus 6 what? 6x. Okay. Then we have D. D we are having 5, which is plus 3 over x, 3 over x greater than or equal to 8. So we may have some numbers like this. Okay, D, then E. Last we have E. We have a quarter, 1/4 of x minus what? X minus 1. Being less than x over 3. So we want to solve this. They want us to look for the value of what? Of x. Who can tell us the answer to A? Because you may find you have got already the answer to A. Yes, what is the answer to A? A, you have x minus 1 less than or equal to 5. The way you solve the other questions is the same way you also have to solve this. X minus 1 less than or equal to 5. So they want you to solve for x. So meaning this one take it to the opposite what? Side. So you can only take this one to the opposite side by adding 1 on both sides. So plus 1, then you go on the opposite sides. Remember, additions and subtractions, they don't change the order of the what? Of the inequality. Okay? So that's why now this one and this one cancel. So this side will remain with x, and x will be less than or equal to 6. And that's the answer. Okay? Don't you see how easy and simple they are?
Yes, teacher. No.
So we can do the same to B. We can do the same to B. Because B also it is just similar. B, they're saying they want us to look for x again. And there we have x plus 2, which is greater than what? 6. So we take the 2 to the opposite side. We are looking for the value of x. So we subtract 2 on both sides. And subtractions, they don't change the order of the inequality. So that's why here this one remains, okay? When you subtract 2 on both sides. So this side will remain with x, which will be greater than what? 4. And there, that's also another answer to B. Okay. That's how we should work out these numbers. Even C, the same. We collect the like terms. The same way we work out to the other equation solving what like that. The same thing. The only difference here is during division. When you are dividing by a negative and when you are multiplying by a negative, that's the most sensitive thing. But the remaining things, the operations are the same. So I think I can rub off here. We do what? We go to C. Now C, we are having 2x, which is minus 3, and this is less than or equal to 13 minus what? 6x. So what we do, we collect the like terms. Okay, I can bring this 6x to this side by adding 6 on both sides. So I can say this is 2x plus 6x. Because I want that 6x will come this side, it will come this side by addition. So plus 6x minus 3. This is equal to 13 minus what? 6x, and then plus 6x. Plus 6x. So 6x and 6x cancel. So 2x plus 6x. Oh, sorry, here I'm using equal. It's supposed to be less than or equal to. Hello, what's that? So here, yeah. Okay, it's supposed to be less than. I think that if you are not used with them, you easily forget. Okay? So like that. So 2x plus 6x, we get 8x minus 3 less than or equal to 13. The opposite there will remain 13. Okay? So I think I can remove also this. Then still we want to get the value of x. So meaning we take also the 3 to the opposite side through additions. So negative 3, okay, minus 3, then plus 3, less than or equal to 13 plus what? Plus 3. So this side will remain with 8 what? X. And the opposite side there, it will be less than or equal to 16. Then after that, we are going to divide both sides by what? By 8. Okay, dividing both sides by 8. Remember, this is positive. So we are dividing both sides by a positive number. So therefore, this one here won't change the sign. The order won't change. So x will be less than or equal to what? 2. Okay? Are you seeing how my steps are? Don't make mistakes, because these are inequalities. Is C clear?
Yes, teacher.
All right, now we are going to go to D, and then we look at E. Yeah, so that I'll reserve here some numbers for you. I think there are some exercises here. Yeah, there must be some numbers here which I'll give you so that you can also work out. Yes, indeed. All right, let me take you to D. I can rub off again here. So that we can look at D. So D we are having 5, which is plus 3 over x, and this is greater than or equal to what? To 8. Okay. Let us see. Now, what we can do here is we can do this step because there's a fraction. There's a fraction there. Now, when there's a fraction, we need to make it linear, so that there's no fraction, and we can do that by multiplying both. Okay, multiplying both sides by, we have to multiply both sides by x, because this x is the LCM, the denominator. So we have to multiply both sides by x, so that the fraction goes away. Because here we are having 5 here, plus 3 over x, and then being greater than what? Or equal to 8. So multiplying both sides by x, I'm going to multiply this 5 by x first, like this. Okay. I come to this one also, I multiply it by what? By x. And then also I come to 8, I multiply it by what? By x. Okay. Like that. So when I multiply them by x, here I will get 5x. I'll get 5x here. Then the one in the middle, this x and the other x, they go to heaven. They only leave us with 3 here. They cancel. These two x's cancel. And this will be greater than or equal to 8 times x, we get 8 what? 8x. So me, I have performed this like this, but another person may have performed a certain another way. Okay, another person can first take this 5 to the opposite and then cross multiplies. It is also okay. So now after that, I need to make it to get the value of x. So I collect the like terms. Okay. So I subtract 5x on both the sides. So 5x minus 5x, this is plus what? 3. It will be simply greater than or equal to, also here 8 what? X, which is minus 5 what? Minus 5x. So this side I remain with 3 greater than or equal to 8x minus 5x, we get 3 what? X. Okay? Like this. Now when you reach here, we need to get the value of x. So first maintain it there like this. Okay? So I'm going to divide both sides by 3 by 3. Okay? So that you'll find, so make sure here you don't just so what do we get here? You'll find that we will be able to get this side 1 greater than or equal to x. X this side. Okay? Like that. But now the moment I interchange, if I bring this x to the opposite side, because we always do these things to those ones where there is an equal sign. When I bring this x this side like this, and I write here x, and then I take one to the opposite side, okay? Now this sign will reverse. It will reverse like this, okay? It will reverse, okay? The order will be reversed. The order will be reversed. Otherwise, if you don't reverse, then it will be wrong. It will be wrong if you don't reverse. So either you write your answer like this or like this. Both of them are the same. Okay? So this is the answer to what? To part D. So you can either leave it like this or you can give it like this. Okay? You reverse. If you interchange, if you make this x to come this side and then one to the opposite side, then the sign also should change. 1 is greater than or equal to x. X is less than or equal to 1. Those two statements are the same. If I say I'm older than you, and another statement says you are younger than me, they are the same. They are the same, okay? So that is D. Let us see E. Let us look at E finally. The time is not on our side. So E we have, let me see, a quarter. E we are having 1/4 of x minus what? Minus 1. Okay? Being less than x over 3. Less than x over 3. So now when you look at this, we can begin by cross multiplication. Okay? We can say by cross multiplication. So by cross multiplication, we are going to have this side 3 multiplying x minus what? 1. Okay? Then less than. Then the opposite side 4 will multiply the other one. 4x. This is what we obtain when we cross multiply. Okay? So when you open the brackets here, we get 3x. And then minus what? 3. This is less than what? 4x. 4x. Okay, so there's just power blackout here. I think we can finish that work and we stop there. So this is where we were looking at. So I was saying that we can take D3 to the opposite side by adding. So this is less than what? 4 what? X plus 3. Plus 3. So this side we are going to remain is 3x. That is less than what? 4x plus what? Plus 3. So then after that, I can still bring the 4x to this side through subtraction. Minus 4x, and then this will be less than, that is 4x minus what? 4x, which is plus what? Plus 3. Okay, plus 3. So this side 3x minus 4x, we get negative x, which will be less than positive 3, which is on the other side. Now when you reach here, you don't stop there. There's a negative on the x, so meaning you need to remove that negative simply by dividing both sides by negative what? Negative 1. Okay, but now when you are dividing, do not forget, like me, I had forgotten here, when you are dividing, that this inequality has to reverse, because this is you are dividing by negative number. Okay, so it has to reverse, so that when it reverses, now this side you'll get positive x, and it will be greater than negative what? Negative 3. So this is the answer. That's the answer. So you shouldn't forget, your learners always makes errors when they are what? They are performing those divisions and the multiplications of negative what? Digits. I mean of inequalities by negative numbers. So you have to always not forget that, okay? So I think this is where we are stopping. I'm going to just send you some exercise questions for you to work out, okay? So we shall meet on Friday, unless if there's a question.
No questions.
Okay, fine. So I'm going to send the work, you'll be able to do also some numbers. Okay, have a good day.